In the continuation of part 1, we start part 2 and proceed the chapter. Question 5. Find the values of A and B if 3 plus root 2 upon 3 minus root 2 plus 3 minus root 2 upon 3 plus root 2 is equal to A plus root 2B. We have two numbers and we rationalize both numbers separately like this. Just like previous question, we multiply numerator and denominator by its conjugate. So that is 3 plus root 2. 3 plus root 2. Similarly here, we multiply numerator and denominator by the conjugate of the number, that is 3 minus root 2. 3 minus root 2. And right side will be the same, A plus root 2B. Now we solve it. So 3 3s are 9. 3 into root 2 is 3 root 2. 3 into root 2 is 3 root 2. And root 2 is 2. Here we use identity A plus B, A minus B. So that is A square minus square of root 2. Similarly here, 3 3s are 9. 3 into minus root 2 is minus 3 root 2. Now we multiply by minus root 2 to 3. So we have minus 3 root 2. Minus minus plus. Root 2 into root 2 is 2. Here we have the same identity A square minus B square. So we can write like this. Is equal to A plus root 2B. On solving more we get 9 plus 2 is 11. 3 root 2 plus 3 root 2 is 6 root 2. 3 square is 9 or root 2 square is 2. In this bracket 9 plus 2 is 11. Minus 3 root 2 minus 3 root 2 is minus 6 root 2. 3 square is 9 and root 2 square is 2. Right side will be the same. Now we open the bracket. So this is 11 plus 6 root 2 upon 7. Similarly here, 11 minus 6 root 2 upon 7. Now we take LCM, so we get 7. 11 plus 6 root 2 plus 11 minus 6 root 2. A plus root 2B. Minus 6 root 2 plus 6 root 2. By the way cancel out because both have same opposite sign. Now we have 11 plus 11 is 22 upon 7 is equal to A plus root 2B. Or we can write 22 upon 7 plus 0 into root 2 because 0 into root 2 is also 0. Because here we have on right side we have the value of root 2b. So we have to write the same value root 2. On comparing both sides, A is equal to 22 upon 7 and B is equal to 0 because root 2 is common here. So B is equal to 0. Now, question 6. Representation of root 2, root 3 and root 5 on number line. So first we draw a line that is called number line. We mark the point at equal distance. Suppose this is 0. On right side we take positive values, real positive number, or positive integer, we can say on left side we take minus numbers. We measure all distances from 0. For root 2, we make an angle of 90 degree at point 1. This is called 1 unit distance. And from this point, we cut the same distance. It means this is also 1 unit. And join this point. This is root 2 unit. Now we put our compass here and take an arc like this. Because suppose if we give the number or name, suppose this is A, this is B, this is C. So OB is equal to OC. Distance OB is equal to distance OC. Because we have to represent these numbers on number line. So our number line is here. So we represent this distance on the number line. Now verification. Clearly, this angle is 90 degree. So triangle OAB is an right angle triangle. OAB is a right triangle. Now we use Pythagoras theorem. In triangle OAB. As we know that h square is equal to p square plus b square. And opposite side of 90 degrees is called hypotenuse. Perpendicular is 1 unit. And base is also 1 unit. As we know that 1 square is 1 and this is also 1, so this is 2. H square is equal to 2. So h is equal to root 2. And what is h? OB. So distance OB also is equal to OC. Is equal to root 2 unit. Similarly for root 3, or first we take root 5. For root 5, we draw a number line, take 1 unit digit, 1 unit distance of -1, -2, etc. Now we draw an angle of 90 degree at point 2. This is 1 unit distance, this is 1 unit distance, so total is 2 unit distance. Now we take 1 unit distance on perpendicular and join to 0. If we want to give the name, so we can write like this. This distance will be root 5 units. Verification. Just like this. In triangle, right triangle OAB, by Pythagoras theorem, h square is equal to p square plus b square. Perpendicular is 1 unit and base is 2 unit. 1 square is 1, 2 square is 4, so this is 5. H square is 5, so h is root 5 units.